Hi.
Disclaimer, disclaimer, disclaimer. The following hour of programming has been custom tailored for a specific audience. While a run-of-the-mill broadcast will supply off-the-rack entertainment, the content covered over the next hour has been stitched together by only the finest threads of conversation, methodically measured down to the last fold of each individual audience member's brain, so that when you think, the show will think with you, allowing fluid lines of thought as you make each mental stride, showing off your finest of features. You will walk into any room confident that you will turn heads in a current fashion that will accentuate your glamorous ability to figure. If you have yet to be fitted, have no fear. Raise your arms out to the sides and take a deep breath. It's time for This Week in Science, coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good, whatever you want to call it, Kirsten.
I call it Thursday. It's good
Some
Thursday.
will call it Thursday. Some will hear this and say, no, you're wrong. It's Tuesday.
It's Tuesday
Other
today.
people
What are you
will be-
talking about? Is that me or Justin who froze? It's a good look for him. It's a good look for you, really,
know.
freezing like that. There you go. Yeah, that's the pose. Strike a pose. Vogue. You were saying?
I was?
Yeah, okay.
Welcome to This Week in Science.
Welcome, everybody. This is This Week in Science. I'm Dr. Kiki. And Justin's over
I
there.
am Dr. Jackson Fly.
You wish. You're like a doctor, like Dr. Phil's a doctor.
Okay, me and Dr. Phil, doctors. Doctor.
Exactly.
I'm not a
Anyway.
doctor. I wouldn't want to be a doctor.
No,
Because
people
I
ask you
think
too
people
many
ask
questions.
you questions about stuff all the time that has nothing to do with whatever you're a doctor in. It's like the cat who just won the Nobel Prize. He was saying he has a big responsibility to field questions from every direction on any subject. Probably
Anything.
nothing to do with the research that got him the Nobel Prize because it was very complicated. not a lot of people have any depth of understanding of it. But he'll get asked everything, even whether or not to buy insurance on an appliance. People once you have a Nobel Prize, it's like, well, I got this question I could ask my friend Stewie, or I know this other guy. He's got a Nobel Prize.
I'm going to ask him.
Take his
A little
advice.
bit more credibility. Yeah.
Get a stock tip from him.
I think you're right on that one. But yeah, I'd love to congratulate all the Nobel Prize winners this week, especially Nobel Prize winner in physiology, my area of specialization. Yes, specialization. For the...
Hey, you're a physiologist?
I'm a physiologist.
I didn't know.
You didn't know?
I know. I thought you were a neurologist.
Yeah, I'm a nerdologist.
No,
Physiology. It's the basis of the neurophysiology that I studied. But what
neuro? Okay, well, as long as it's in there. As long as I for this whole time just didn't have it wrong.
No, not at all. No. But he, the guy who won, he won for the in vitro fertilization technique. Special technique, the award in physiology, which has helped, countless people around. Well, I guess probably countable since there are records for these things, but lots of people around the world over the last 30 or so years. Lots and lots and lots, which I think is great. So, if anyone you want to ask questions of, maybe he's the guy. But we have more than just Nobel Prize winners this hour. There's a lot of science that actually happened. Not science in the past, but science of the here and the now. The science of this week in science. And so I brought stories about sun confusion, talking to the brain, and some bad moos.
Some
What did
what?
Bad moos.
Bad moves. I've got food poisoning.
No, that's
I also
awful.
have lung cancer.
Oh, Justin.
I seem to be attracting flies. And gosh, this is asthma. I've got asthma. This is looking bleak for me over here. Ooh, and I've got ice somewhere where people didn't think you could have ice, which
Wow.
also sounds bad.
All right, so I'm excited and interested in your stories for this week. So let's get started, right? Let's get this party
Bring it.
started. All right, so let's get started with the confusion first. Let's just get the confusion out of the way. So, a paper in Nature this week is causing a lot of hubbub in the media circles. What is the sun doing? Normally, people think that when solar activity goes up, this is the leading hypothesis about how the sun, solar activity, and climate are linked. There's this hypothesis that people think the sun gets more active and the Earth heats up a little bit. But this paper that was just released in Nature, it suggests that that is not necessarily the case. It is only a study looking at the past, or looking at 3 years worth of data from 2004 to 2007, data that was collected by NASA's Solar Radiation and Climate Experiment satellite. It was looking at the spectral composition of sunlight hitting the planet and coming into the planet. They found that during this 2004 to 2007 period, which was part of the declining phase of solar activity, so there's a decrease in sunspots during this time period, and 2009 was the highest, where there were absolutely no sunspots for a really long time. They found decreasing solar activity and increased temperature of the planet. So instead of sun gets hotter, planet gets hotter, sun gets more active, planet gets hotter, sun gets less active, planet gets cooler, that's not what they found. They found sun gets less active, planet gets hotter. So it was a disconnect in what the commonly accepted understanding of this connection actually is. So people have kind of been poring over this and over this and over this. The researchers, however, Joanna Haig, who's an atmospheric physicist at Imperial College in London, and the colleagues that she did this study with, they have been reiterating that, number one, this study only covers 3 years worth of data. This does not take into account any other solar activity period throughout history. It's only 2004 to 2007, and they just figured this was important data. They saw the trend coming out, and they're like, we have to publish this. So
yeah, it's especially rough because the real solar cycles are like an 11-year cycle of the peak and valley for any one cycle, and so looking at a fragment of one of the cycles, it's not a lot of data. It's an interesting correlation because it can refute at least that there's a direct correlation all the time. But needs more time.
And people have been looking at sunspot activity and just temperature, but in terms of looking at the spectrum of light and the measurements of wavelengths of solar radiation, that hasn't really been done. So this is the first study of this kind of information that they're looking at. And so according to Nature's news website, this is a story published by Kieran Schirmeister. Kieran writes that Haig's team compared sources, and source is the measuring equipment that they used. It's the experiment that's on this satellite. Sources solar spectrum data with wavelengths predicted by a standard empirical model based mainly on sunspot numbers and area. And then notice these unexpected differences. The amount of ultraviolet radiation in the spectrum was 4 to 6 times smaller than that predicted by the empirical model, but an increase in radiation in the visible wavelength, which warms the Earth's surface, compensated for the decrease. So there was less ultraviolet radiation, but more visible radiation, and that visible radiation could have been involved in some of the warming of the planet. However, people might also ask, okay, there's still warming. What's going on? The visible wavelengths were still involved. Those are probably involved in the heating. Why are we even talking about, this is the reason that we have climate change and global warming and all this kind of stuff. The sun is the driver of this. Well, that's not true either. That's not something they looked at the effect of, of the solar forcing as opposed to carbon dioxide and other greenhouse gas forcings. And they said that this is probably about the sun's effect in warming was probably about 10%. And so the researchers say here the findings could prove very significant when it comes to understanding quantifying natural climate fluctuations. But no matter how you look at it, the sun's influence on current climate change is at best a small natural add-on to man-made greenhouse warming. So the question here is, the big point in all of the media hype that's coming out of it. I mean, there are stories on this everywhere. The big thing to keep in mind is don't look at the headlines. Don't pay attention to the craziness that it's apt to bring, because this is, like I've said already, this is a very short time period. It's one very small data set. Yes, it is important in the long-term scheme of understanding things and developing better models for understanding how everything works and getting an even more accurate picture of understanding everything. But at this point in time, we can't make, we can't just say, the climate, we can't make big judgments based on this one small study. And so don't jump to conclusions based on a headline that you may or may not read. So,
well, so far the bulk of the research has come through that sunspot activity is not in any way driving global warming, not in any way, shape, or form.
And this still stays. This is still within the reach of that. It's not not sunspot activity, but solar radiation wavelength. So it's looking at a different parameter of solar activity. Still. It's not the disconnect. It's basically falling in the same category of solar activity. Of course, solar activity affects the Earth's temperature, and of course, it's a part of heating the Earth. I mean, that it's a big fireball in the sky. There's a lot of radiation hitting our planet, but when it comes to expected changes with time, there are increases in temperature that are occurring outside of the natural fluctuations that are based on this, that come from the sun.
Right, and the whole deal with the planet having chlamydia.
Yes, chlamydia.
Is that
chlamydia.
Any heat that gets here any heat that enters will be trapped for a longer period of time. So that's part of this. So in that sense, then yeah, absolutely, sunspot or solar heat wave, radiations will contribute to global warming, because any more energy put in that's harder to get out again accelerates the whole chlamydia deal.
Right. Exactly. So the analogy, it's not a perfect analogy, but the analogy of a blanket, a greenhouse gases encircling the planet like a blanket, it kind of works that way, where that blanket insulates, and the rays from the sun, they can come in, but then they just stick around and they don't get out. Heat us up. Yes. So anyway, don't be confused, people. It's okay. It's just one little study. There's more coming. We'll learn more later after, probably in about 11 years we'll have another cycle under our belts, and maybe they'll look at this data some more as we move into the future. Unfortunately, this stuff is like so hard.
Unless we don't have those 11 years. Because
Why?
new research finds a giant asteroid on course to hit Earth has a 99% chance of hitting us sometime in the next 6 months. That's not true. I made that one.
Okay, I was like, I haven't heard this from my astronomer friends. Come on.
I just thought that would be funny to say on there. No, this is an asteroid though. So water, ice on asteroids has not been found but once by researchers. According to a new study, though, it may be much more common than expected. So 2 teams of researchers who made the national headlines in April of this year showing the first evidence of water ice and organic, which is a loose term, organic molecules on an asteroid have now discovered that asteroid 65 Cybele contains the same material. So a second asteroid has been discovered with icy water and organic material. This discovery suggests that this region of our solar system contains more water ice than anticipated, said University of Florida Professor Humberto Camp.
All right. Jackson Fly has frozen. Alex, can you mark this? Bink! So when I'm editing, I can be able to see that in the file. Whoop! There he is.
You can try.
Yeah, if you can hit M on the keyboard for the audio recording, that would be awesome. But we can keep moving forward. Hopefully, we'll get Justin back in a second. Dope. Somebody here just in the chat room said you have to calm their wife down about 2012 again. Well, yeah, maybe you do, actually. There's a story out that somebody sent to me this week related to the timing of 2012 and the new analysis by an expert in the area of Mayan archaeology and history and their writings has determined that maybe the basis on which calculations were made earlier wasn't exactly correct, and that the assumptions that were made a while ago aren't necessarily right, and that the timing of 2012 might actually be off by like 50 to 100 years, and in either direction. So we could have already missed it, in which case...
Whoa, you mean the world isn't even here anymore?
Yeah, the world's not here anymore.
The world's already gone?
Yep. We already missed it. Or, hey, maybe 2012 is yet to come and we just haven't gotten there yet. So in either case,
must be some giant bird deity is going to fly down and be all caw, caw. Like, some F-16s and shoot that bird down. Just a couple missiles and we're good. We're good.
Take
for
it out.
Millennia.
All right, tell me the story about the...
I will return with, my minions of doom. They're going to come to a world with armored militaries and drones and all kinds of stuff. They're just going to be massively outgunned and totally disappointed. They're going to wish they'd stayed in the dark ether world.
Who's they?
All those, things that are going to rise up and be like, ah,
Oh, right. Them.
all the prophecy creatures.
Right. Yeah, they should just all go back to bed. There's, yeah. You can't really trust the timing too much. We might really kind of be off on the dates a little bit. Anyway, tell me the story about the asteroids. Justin, you were...
Yeah. So this asteroid... I was kidding. I'm not actually. They found another one that has water on it. So basically, finding one asteroid could have been fluky. Could have been maybe you got to check the instruments. Maybe don't trust the research that was done to find it. Having found 2 sort of confirms that it's much more. Potentially, water is much more frequent at least in our solar system than we had previously thought. And it does. I'm showing you this piece of paper, but it's not even the right study. One of the theories is that all water, including the water that helps form our atmosphere on planet Earth, all came via asteroid, potentially comet and asteroid.
Comets. Yeah.
Right. Bombarding the Earth over the years, bringing with it bits and bits of ice and perhaps even a couple large hits that were voluminous. But that all of the moisture that's here didn't form as the planet formed. It wasn't a gaseous thing. It wasn't like there was water or ice that sort of was collected on this big ball of rock. But that we were at one point a waterless rock, and through bombardment collected all the moisture. So lends some credence to that theory by finding another asteroid that is water ice laden.
Yeah, that's really awesome, because if you find one, it's like, okay, well, all right, we found one, but when you find two, or maybe in the future we'll find more, it does add to that, the certification of the idea that this really could be where water came from, that maybe that water crystallizes, that it gets into an ice form far off in the solar system, on the edges of the solar system somewhere, or even outside our own solar system, and then comes into our solar system via comets and asteroids. And maybe that's where all the waters come from. I think that's neat. But who knows? Who knows? All we know now is that there are 2 asteroids with water, right?
And 2 asteroids, number of comets, a couple of moons, our moon, Mars. We're finding it everywhere now. Now it's hard to find a dry spot in the solar system.
That's true, which is pretty cool. It's pretty cool. Next step is finding the life elsewhere in the solar system.
You know what? I found it. I know
did you? Yeah.
I know where there's life in our solar system. I know. It's here on Earth.
Good job.
Yay! We're there. You don't need to keep going. There's abundant, incredible amounts of life, voluminous amounts of life here on this planet to explore and discover. There's a new, the latest, what is it called? The marine census.
Yes.
Where they go through and sort of calculate how many life forms they've discovered. And they believe that they're
census
just
on marine life. Yeah.
Tip of the iceberg, they're saying. There's so much in our watery depths of our planet that we have yet to discover, that if you take all the marine life that we're aware of, there's much more. Of course, in that, they're going to be counting some bacteria. We're the bazillions of species of bacteria that we've discovered are existing in our oceans that we weren't aware of 10 years ago. But even in a life exploration on this planet isn't nearly finished yet. We have a lot more ground to cover, or water to explore.
Yeah, I think that's always an interesting point, is that there's so much that we have not explored and that we don't know about here on our own planet. It'll make exploring elsewhere, it's just going to be add that much richness to everything, but there's still so much more here to explore. There's, we have to take our resources and divide them up in a reasonable way to make sure that we keep putting them into our own planet, figuring out how our own planet works, how to keep living on this planet in a sustainable manner. You think about every time you hear about a new species being found, there are 10 other species going extinct at the same time. So
we need to find more so we can keep up.
Let's find more. Let's keep up with it. Let's go.
I don't think it works that way. Yeah, we're probably losing lots of species that we're not even aware of.
Yeah. That we haven't found yet.
And we have done that before. We have declared a few species in the past as being extinct species of the past, only for them to show up and be like, "No, I'm here.
I'm still here."
And then lose them again. We go to research them and trample over their nests or whatever. We've lost a couple. We've lost a couple that we rediscovered after thinking they were gone.
Yeah. Well, along these lines, I'm going to skip to a story that I think is really interesting. It's not species, but this story from Science Daily that actually is being reported by National Geographic's expedition to India. They're looking at languages that are going extinct. And in the process of looking for these endangered languages, excuse me, they've actually found a language that unfortunately is in the process of going extinct, but that nobody even thought or knew existed. They found a brand new language that just brand new language. So they've gone out to the northeast corner of India. They've gone to an area called Arunachal Pradesh, and linguistically, it's very difficult to study in this area. The article in Science Daily says that a special permit is required to enter the region. Not many people, linguists, have gone there to actually draw up reliable lists of the languages that are spoken there. The locations of those languages, or even the number of speakers. And so there's this National Geographic expedition that's called the Enduring Voices team. And within the Enduring Voices project, they're going out to try and do all this. They want to document these languages that have been thus far relatively ignored in India. They went into Arunachal Pradesh in 2008 for looking specifically for two poorly known languages called Aka and Miji, which I'm probably not saying right, but they were known to be spoken in one particular area. And so the linguists went in and they started listening to and recording the language. And as they were listening and recording, they noticed words and some other grammatical features that just didn't mix in with the two languages that they were paying attention to. And they found a brand new language in there that they're calling Koro. Nobody's ever reported it before in the scientific literature, and it's completely distinct within the region. One of the researchers said, "We didn't have to get far on our word list to realize it was extremely different in every possible way." They had to reach Koro villages by crossing mountain rivers, by bamboo raft, and then sitting in stilt houses and making these recordings from people sharing their life stories and getting the vocabularies written down. They found that Koro is completely distinct via its inventory of sounds are different from those in the area, other languages in the area. The way that the sounds combine to form words are completely different. And then words are also built differently and our sentences. So the grammatical nature, the vocabulary, the nature of the vocabulary is completely different from other languages in the area. So Harrison, the researcher, says Koro could hardly sound more different from Aka. They sound as different as, say, English and Japanese. But it's strange, though, that, yeah, which is really different, right?
Like totally.
Are you a Valley boy all of a sudden? But the researchers found that the Aka and Koro speakers didn't see the differences as being that dramatic. Aka speakers considered their Koro speaking neighbors and cousins as just speaking a dialect of the same language that they spoke.
Like, duh, like, don't get grody about it. Like, oh my God, that's totally like way the way it is. Yeah.
Like, gag me with a spoon. Oh my God.
Yeah. Like, yeah.
Aka is the traditional language of the region's historic slave traders, and the researchers are hypothesizing that Koro might have come from the slaves, and it's possibly that the slaves may have come up with this language to have a distinct language from the slave traders. Currently, they only know of about 800 people who speak this language. Very few of those people are under the age of 20, and they're saying that if they had waited 10 years to make this trip, they would not have come across nearly the number of speakers that they found today, and this language is definitely on its way out. So they're really excited to have found this far away, remote, and dying language before it disappears.
Yeah. Or see again, we do these explorations far, far out into the remote because that's where discovery can take place. They could have gone down to the northern LA Valley and tried to find the last Valley resident using
Find
Valley
the
Girl
last
speak.
Valley girl.
Yeah, I mean, why travel out? You want to rescue a language or go to? You didn't have to go that far. It's all right here. Life is here. We got endangered languages right here. You don't have to leave California. We have everything here.
Wow, I'm totally envisioning this is like a movie plot or something. You know, the search for the last Valley girl. It could be fun. It could be very fun.
Are we at the break, or do you want me to blurb something?
Blurb something. Give me a blurb.
Okay. Bacteria may be to blame for asthma attacks in the children. Doctors says here, doctors have long known that viral infections can bring about asthma attacks and shortness of breath, coughing, wheezing associated with them. But while viral infections cannot be treated, scientists at the Danish Pediatric Asthma Center, University of Copenhagen, have discovered that treatable bacterial infections also cause asthma attacks, which could be that's pretty huge. We have found a significant relationship between bacterial infections and acute asthma attacks, above and beyond the expected relationship between viral infections and attacks. So it could actually even be that bacterial infections are producing a large number of these asthma attacks. And according to this study, antibiotics can cure a number of these cases. Indicates that bacteria can exacerbate asthma symptoms even if they aren't infected with the virus. And they open up an entirely new method for treating severe asthma attacks. Wow. So being able to use antibiotics to treat asthma attacks in children would be revolutionary, says Professor Biscard Malmalfi.
It just sounds like a new way to lead to more antibiotic resistance in bacteria.
Yeah, it could be.
Yay, more antibiotics. I mean,
it could
yes.
be, but on the other hand, to identify that something that was considered to be unfightable because it was a virus, that they didn't have any antivirals to treat in these asthma patients, to figure out that asthma can actually be contributed to, or a catalyst of it can be these bacteria, that's huge. That's a lot of wheezy kids who don't need to be in the inhalers.
That's a good way to describe it.
Or they could just put the antibacterial in the inhaler.
Yeah. That would be one of the best delivery methods. If people are already using the inhaler, that would be absolutely one of the best delivery methods. Get it direct to the source. Anyway, bacteria contribute. Yeah, bacteria contribute to everything. I'm sure.
Aren't they involved? They're in the gum disease. They're in maybe
which then leads to heart disease. Yeah, cancer, asthma, gut disease. Yeah, bacteria involved in everything.
Yeah. And they're also involved in all the good stuff. They're not just the bad stuff. They're how you digest sugars and a lot of other nutrients. Without bacteria in your gut, you would die from starvation.
Yeah. I think the study that comes out and is like, bacteria are found not to be involved in, that'd be like, oh, that's interesting. Anyway, we are about at the break. That was a good blurb to send us into the break. This is This Week in Science. I'm Dr. Kiki with Justin Jackson. We'll be back in just a few moments.
Shows the way to go. You can
I'd like to thank Audible.com for sponsoring this hour of This Week in Science. Audible.com is the leading provider of audiobooks, downloadable audio enjoyment of literature, podcasts, periodicals, all sorts of stuff like that. They have over 75,000 different titles in a variety of genres. And Twis has found a lot of science-based material in the Audible library. There are a lot of sciencey books in there, which is great for scienceophiles like myself and you people who are listening right now. And you can get a free audiobook download from audible.com in a very easy way. All you have to do is go to audiblepodcast.com/twis, TWIS. It's audiblepodcast.com/twis, and sign up for a trial membership with audible.com. As the joining gift, they give you a free audiobook download. So you can enjoy books like this month's book club book, Dark Banquet by Bill Shute, and which is a great book about vampire bats and other blood-feeding organisms. It's a great read. We interviewed Bill a couple of, I don't remember what month it was. Maybe it was last year even, but we interviewed Bill, and it was great fun. The book itself is very interesting. You can find all sorts of books like that at audible.com. All sorts of great reading that's meant to be heard. You can download it, take it with you wherever you need to go with your portable audio device, or just sit at your computer and listen. Go do that right now. audiblepodcast.com/twis for your free audio book download. And additionally, I would like to reiterate that our Twis book club book of the month is Dark Banquet. Dark Banquet is kind of themed up with Halloween, All Hallows Eve, the dark, the night, creatures of the night. It's a great biology story about these creatures. You can try and pick up that book and read along with us for this month of October. It's a good, fun, fast read. And next month, if you want to get on things and get your book ahead of time, the book for next month, which I believe is going to be released here in the United States very shortly, if it hasn't been already, is Bad Science by Ben Goldacre. It's been out in the UK for a while, but we've been waiting for it here. Bad Science by Ben Goldacre will be our November Twis book club book of the month. And I'd like to thank Richard Baker also, who has agreed to kind of take up the Twis book club announcementing and keeping on top of stuff there at our website, twis.org, in terms of book club materials. So we will be putting announcements up. The books will keep coming, and the book club is a great way to, get more science learning in when you're not listening to Twis. Join on in.
Answers lie somewhere within this scattered plot. Our first assumptions were correct. Just prove the rest. It's hard. The methods and hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see.
And we're back. More This Week in Science.
Oh, yeah. We got lots more science.
If you're just tuning in, I am not a doctor, but I have been studying opinionology my entire life. And my co-host is a real doctor. She's got paperwork to prove it. Dr. Kiki Sanford.
Woo! Yeah, that's me. Hey, folks. We have science to talk about. There's some great stories out here, aren't there? Like this one that was sent in by Monkey. He found it occurs while accelerating intelligence, but it's also, there's a release out of the Salk Institute that the researchers at the Salk Institute in La Jolla, California, have mapped functional connections between retinal neurons at single cell resolution. Now, what does that mean? Basically, these researchers have been able to improve the resolution of their study of circuitry of neurons, how they connect together, to such an extent that they've set up a system where they've been able to look at how cells in the eye communicate with the rest of the brain and what kind of signals get sent out. The lead researcher, senior author E.J. Chichelniski, he's an associate professor in the Systems Neurobiology Laboratory, says nobody has ever seen the entire input-output transformation performed by complete circuits in the retina at single-cell resolution. We think these data will allow us to more deeply understand neuronal computations in the visual system and ultimately may help us construct better retinal implants. Which I think that the last part of the statement is really interesting, that if they can understand the circuitry and how the rods and the cones within the eye, the light sensing cells within the eye, communicate the information of photodetection with the retinal cells, the ganglion cells that then send information to the rest of the brain. If you have a disorder that affects the retina, you can maybe put an implant in that could replace the retina in a very, very realistic manner that could be almost real, so this kind of a study is really interesting for that manner. The study was published today in the journal Nature, and they've used a new system that has allowed them to actually record these electrical signals generated by hundreds of the retinal output neurons, these ganglion cells. And the recording electrodes, it's just amazing how small, the fine scale that they're looking at here. Retinal ganglion cells are classified based on their size and the connections that they form, according to this press release. And one of the types of cells that they were able to look at they're called midget retinal ganglion cells, which I think is kind of cute. Must mean they're kind of small. The team recorded tiny electrical signals of these retinal cells outputting their signals to the brain, and the recordings were made at over 10 million samples per second. They're sampling the information over 10 million times per second, and with very fine spatial details. So they're really looking at the level of cell by cell basis. What they ended up noticing, they've ended up finding that they had 5 different cell types. They had on and off midget cells, on and off parasol cells, and then small bistratified cells. And those account for about 75% of all the retinal ganglion cells. So there are still retinal ganglion cells that they did not identify, that are still there, that they were not able to get the resolution to be able to actually figure out what they were and what they were doing. So it's just fascinating. The researcher says just by stimulating input cells and taking a high density recording from output cells, we can identify all individual input and output cells and find out who is connected to whom. They ended up finding out that single ganglion cells were responsible for being connected, and populations of these ganglion cells, so like a bunch of midget cells in one area, were responsible for a whole bunch of rods and cone cells, and then another ganglion would be responsible for another bunch of rod and cone cells. The rod and cone cells they're the ones that interact with the light. So photons of light come in and hit the rod and cone cells. The rod and cone cells, then there's a chemical reaction that takes place that then leads to creating an electrical signal that is then sent to an intermediary cell that's called a bipolar cell. These bipolar cells then connect to the ganglion cells, and the ganglion cells then actually connect into the brain via the optic nerve. The axons of the ganglion cells are actually what make up the optic nerve. And it's just really neat. They ended up finding that populations of on and off midget and paracell cells each sampled complete populations of cones sensitive to red or green light, with midget cells sampling these cones with receiving strong input from cones sensitive to blue light. Only off midget cells received it from blue light. Anyway, there are a bunch of very specific details in here, but the crux of this story is that is what I mentioned at the top is basically that if we can model this, if we can figure out how things connect to each other very specifically within the brain, it might lead to some really interesting treatments as we move into the future for disorders and disease. What you got, Justin?
A new study is recommending that untrained bystanders attempt CPR.
Yeah, what?
Yeah, it makes sense.
That's never what they've said. It's if you're not trained in CPR, don't attempt it. You could kill somebody.
Now they're saying even if you're untrained, you should try it. It's better than nobody doing anything. But what they're also recommending, which makes sense, they're also recommending that you skip the mouth-to-mouth resuscitation and focused on the chest impressions. Now, what they found is really the lungs aren't as important. You can go quite a bit longer without the air, but if your heart isn't beating, that's really where you're going to die. You're not going to run out of oxygen to the brain. You're just well, that's where you need to get the oxygen there. And that the lungs really will jumpstart themselves once the heart is beating. The heart beating is the main thing that needs to take place. And it doesn't expressly say that you have to do away with the mouth-to-mouth, but it really is one of the recommendations that you don't necessarily need to do it. That the chest compression is so much more important that you just do that. So they did a study. It's published in the Journal of American Medical Association, and they found that the simplified version of CPR improved the odds of survival by 60%. So that's a pretty incredible upgrade there. So that part where they, pump the chest a few times and then do the air, they're saying don't stop doing the chest compressions. Just forget the breath part. The chest compressions is where you're going to bring them back. They also upped the time. They've also upped the number of chest compressions that you're to give. It's now 3 per second, which if you do the math on that, and the math isn't that hard. That's really
fast.
It's 180 beats per minute, which is jungle. So then it's like, right? So, and it also overcomes, many people are really reluctant to get into the whole CPR thing because it's the mouth to mouth. It's going to be with a stranger and it's a thing and you don't want to. So yeah, this is fantastic. You don't have to you don't have to go and smooch a stranger just in order to save their life. Because, sometimes I guess people pass. It's like, they were just eating. I saw them with the garlic bread. They were really going after it, and I don't want to.
CPR is different from the Heimlich maneuver, though.
The Heimlich is just you go up, you grab, and then somebody's choking. This isn't a choking thing.
This isn't a choking thing. This is somebody's passed out. They've had a heart attack, something of that sort.
Yeah, the study found that survival rate for patients who received only compressions was about 13%. That doesn't sound very high, but
it's better than nothing?
Well, it's better than traditional CPR, which had a survival rate of 8%. So that's quite an improvement.
Huh. Interesting. I wonder if you should. Yeah, I guess you should wait and see if somebody's trained in CPR. But if there's nobody trained in CPR, interesting.
Or you know what? If they're trained in CPR, but haven't gotten the update on this show, push them aside. Get them out of the way.
I could just,
if you see them going
fights.
in there and doing the breath thing, the tilting the head and blowing into the mouth, tell them, excuse me. I am a recently trained by this radio show I listen to.
Oh dear.
Push them aside and
disclaimer. Well, we'll have a link to the story on the show notes, so you can at least go to the show notes at twis.org to be able to find the source for the story for yourself.
We're saving lives. We're all about saving lives here on This Week in Science.
Yeah.
And, paramedics show up, they start breathing in the mouth. Push them aside. You're saving a life. You're saving a life.
Oh, dear. Oh, my goodness. Disclaimer.
Kristen's very nervous right now.
She's very nervous.
She's not sure that I've read all the details of the study or that this is confirmed, but no, this is now the recommendation. I believe I didn't really, but it's the recommendation from me, certainly, if not from the American Medical Association. It's probably both. Somebody should Google it up on the internet by the end of this show and find out. But I'm pretty sure that's true. You'll save lives. If you don't, if you get involved and the person dies, tell them you heard it here. I'll take full responsibility.
Oh, good gracious. How about some bad moves? Time for some bad moves.
We may have just had one.
That could be very bad. I don't take responsibility for anything you say, Justin.
I take responsibility for all of it, especially because so much of it contradicts that I can always point out that if you listen to everything I've ever said, you'd find that I also at some point stated the complete opposite.
Yeah, probably. I'm sure you have. Yes.
Yeah.
Well, for the bad moves, if you love your meat, it could kill us all. So says a new study published this week in the Proceedings of the National Academy of Sciences. According to the Food and Agriculture Organization, humans are on our way to eat 465 million tons of meat and drink more than 1 billion tons of milk by 2050. That's up from 229 million and 580 million tons, respectively, in 2000. Researchers started with the Food and Agriculture Organization projections for these livestock production levels in 2050. The team leader, Nathan Pelletier, economist at Dalhousie University in Halifax, Canada, then was able to estimate environmental impacts of greenhouse gases that would be emitted by those livestock that we all want to eat and drink of, the nitrogen that is mobilized in chemical fertilizer and naturally fixed nitrogen, and the biomass that those animals must consume in order to grow big enough and strong enough for us to want to eat them. The greenhouse gases, he has basically estimated that the greenhouse gases that contribute to climate change, with all of the assumptions that future growth in livestock production would start at the efficiency of Western livestock production, which is a pretty efficient process, that process would become more efficient by 2050. Even still, he says that livestock production is on track to exceed sustainable levels of nitrogen mobilization by 294% by 2050. And they will account for 70% of greenhouse gases instead of 52% in 2000, and 88% of biomass appropriated by humans. That's up from 72%. So cows need a lot, and they put out a lot in the process, and the more of them we eat or want to eat, the more of them there have to be, and the more impact they're going to have on the planet. And so those researchers saying, hey, this could be bad moose. Anyway, for those of you who like to eat of the meat, maybe you could consider having chicken every once in a while. Possibly. Let's move into the
dinosaur.
That's right. Chicken tastes like dinosaur. Let's move into the minion mailbag and try and get through this pretty quickly. What? Uh,
No,
uh,
go ahead.
uh, 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 uh.
We're good. We're
Um,
good.
yeah, are we good? All right, minion mailbag. Let's ruffle into it. This week, a lot of letters responding to Justin for various topics. The first one
I
that
got more than one this week.
yeah, well, the first one we kind of requested with relation to your economic ideas on energy use, and Ilyich, one of our minions for a while,
Long
says,
time listener.
longtime listener, he says about Justin's theory on the economics of power use. First, I don't believe this for a second. If the total energy use is 100 and my use 10 now, and I use 10 now and I reduce my use to 5, Justin's argument is that this will cause the price to drop so others will use more than the 5 units of energy that I forego for a total use of greater than 100. That just doesn't make any sense. I'm tempted to look up the macroeconomics equations and do the calculations, but I guess that wouldn't work so well on the radio. Second, maybe there is some merit to using up energy so others can't. However, obviously, it doesn't matter whether I burn up a barrel of oil versus someone else burning that same barrel. But what if I buy up the energy and then not use it? Even better, buy the mining rights for oil, gas, and coal and simply leave the stuff in the ground. This makes my operation much cheaper than that of the people who actually want to burn these fuels, so that with a relatively modest investment in mining rights, I can inflate the price of fossil fuels a good deal, reducing their use and making sustainable energy more attractive. Interesting
Well,
idea,
yeah,
Ilyich.
the part of the idea where it's fail is where we assume that the energy system is happening in real time. We flip the switch and so they throw another lump of coal into the power plant. But the reality is all the energy has already been created and is already in transmission to us. Half the energy that's created lost in the transmission before it even gets to us. However, what the energy companies have to do is they have to predict our usage. So if tomorrow we were all using half as much energy, that energy will still have been produced, it will still be in the system, and it will be cheaper. And the number one consumers who will jump on using that cheaper energy is industry. And industry will use that energy to grow. And when industry grows, the economy grows. The chart is like this. I'm going to do this right here for the camera. As we use energy, as our economy grows, they're the same graph. You watch the U.S. economy and the use of energy; they're exactly linked. If energy becomes less costly to us, industry will use more, and when industry uses it, it creates growth, trade. It creates all these things. It's good for economic growth. But it increases our energy usage down the road because as industry grows, its demand to sustain that growth also grows.
Yeah. Okay. I liked Ilyich's idea though of buying up the rights and artificially driving the prices up just by sitting on this stuff. It's a great idea.
I have an acre of truffula trees that I'm sitting
Nice.
on, and I'm not going to let anybody touch.
All right, so here is another person who wrote in and says, I don't usually do this, but after last week's episode of Twist, when Justin made those comments about oil consumption and how we should be using more, not less, I had to write in. For weeks, I've listened to this podcast and for the most part enjoyed it, but time and again, my enjoyment of the podcast has been marred by the ridiculous and baseless theories that Justin expresses on the show. And without much contention from Kirsten.
I marred them.
You marred Adrian.
Said
Yes.
It was marred. I marred a human being. Oh my goodness.
He goes on and on. The stuff that he comes up with are nothing more than wild speculation based on a layman's understanding of the subject matter. And what makes it more annoying is he seems to do this multiple times every week. Okay. Anyway, he goes on a while. It says, anyway, I've gone on too long and strayed from what this email was supposed to be. So I guess I'll wrap up by saying that even if his theory No, wait, I should say hypothesis, seeing that it takes more than wild speculation for something to be considered a theory, on how we should increase our use of oil was right in terms of the economics, it would still not change the fact that the use of oil is a major contributor to global warming, and that it will also quickly diminish the reserves of the resource, which we still heavily rely on.
Right.
P.S.
And
P.S. Adrian does finish it up saying, P.S. I don't have anything personal against Justin. I just don't like when he spews nonsense in my ears.
well, it's okay. You can call it nonsense if you want to, but it's like the famous story of the frivolous ant and the thoughtful grasshopper. We're all aware of this. It's the ant works all day, works hard, and he's saving up because he knows the winter's coming, and this is when you have to work, and when the winter comes, things are going to be tough. And the grasshopper works a little, spends the night singing, partying, sleeps in late, and the ant tells him, like, look, you're going to have to change your ways and be more conservative in your approach to things, because at some point the winter's going to come and you're going to need the food. Grasshopper ignores him. The really frivolous one in that story, though, is the ant, because it's not what your intentions are. It's not how you plan and plot for your own individual life. It's your effect on the bigger picture. And so by giving the advice to the grasshopper to live like the ant, if the grasshopper actually takes that advice, saves up for the winter, next year, it's going to be locust. There's going to be so many grasshoppers everywhere, right? They'll all have survived the winter. They'll all have these huge broods that they normally have because they know they're going to die off en masse each winter. Gigantic broods. Locusts are going to come through, devour all of the crops, because in being more conservative in one year, they will become more abundant in the next. Devour all the crops. The ant won't be able to find sustenance anymore. His little aphid farm in the rose bush will be gone. It'll be down to a nub on the ground. So really the irresponsible one in that story is the ant, because he's so short-sighted. He thinks that because what he's doing is logical and makes sense for his little microsphere, if everybody acted that way, it would be good for everyone, when in fact it would be his own destruction. If everybody took the advice of energy conservation, it would be sowing the seeds for all of our destruction at a much more rapid pace.
Wow. Okay. I invite more people to write in. I think, Justin, you should write Justin's Fables. You know, a new take on Aesop's Fables. I think that could be fun.
Absolutely.
Yeah. Another couple of emails not on the energy consumption front, but on life expectancy. David Eckerd wrote in to say, Justin said that over the last 1,000 years, human life expectancy has doubled. I know that it's more that life expectancy has doubled in more like the last 100 to 150 years. So what was it that we as a species did to extend life? Was it improved medicine? Nope, that was not the biggest contributor to longer life. How about a better diet? Nope, not that either. Would you believe that it's vastly simpler? We stopped excreting in our drinking water. Super simple, very effective.
And by the way, I was completely wrong. Completely wrong about the about how long people could possibly live. Because truly, life expectancy models do have infant mortality as part of our life expectancy, and there was an insanely small percentage. I mean, it was somewhere in the neighborhood of 30% or something like that, just a couple hundred years ago. Something like 30% of children made it past age 5. Child mortality was a major issue.
So high.
Actual life span potential for human beings has been there for quite some time. Our ability to live to be 70, 80 years old, certainly there's many more challenges in doing that in the past, because we didn't have medicine, we didn't have the nutrition, we didn't have a lot of things, but it wasn't impossible, for us to age that. And a lot of life expectancy that says that people on average only were making it to 40 years old, most of that had to do with the early part and not the later part of life.
Right, exactly. So there was another email that was a little bit long from Sherman Dorn, but he goes into a few of these things related to life expectancy and women's ages at marriage and childbirth. So he says that life expectancy was a lot shorter. Yeah, he says about 100 years ago, about 15% of babies born in the U.S. died in the first year of life. Today, fewer than 1% of North American babies die in the first year of life. And then second, he says that the historical maternal ages at childbirth, my memory of classes in grad school is that there is an almost universal pattern in societies without artificial birth control. The average maternal age at the last birth is around 40. And this includes women who died in childbirth, women who died young, women who died well after menopause. So unless Justin thinks that medieval European society had figured out birth control, the average mother's age when her last baby was born would be well into the 30s.
Wow.
Yeah.
You know, and that just actually, because you think about the good Catholic families, you got, if you're going to have 10 kids, you weren't going to do that before you were 25, most likely.
Right. Yeah,
So
it takes a little while. It takes a little while. You got to work. You got to work at it. Exactly. And a lot of things with the size of families and the number of children's that people used to have, and now people in developing countries continue to have, it has to do with child mortality. How many kids are going to die and not reach adulthood? You have a larger family, you have more kids because a lot of them are not going to make it. And that's where a lot of that started. There's logic behind so many things in this world that seems so illogical sometimes. So much. Anyway, that's the Minion mailbag from this last week. I'd love to get you guys writing in, listeners out there. Write in. Tell us what you think. We'll do another Minion mailbag in a couple of weeks, and see what people think about the show in a couple of weeks. Tell us what you think about Justin's energy consumption ideas. Tell us what you think about the stories that we talked about today. Next week's show, will Justin have all his teeth? Only those who tune in will find out. I'd like to give shout outs. Yeah.
I was completely under the impression I was having a tooth pulled yesterday, and the dentist chickened out. Basically is what happened. So yeah, it may be happening this coming week, in which case there's some potential that I won't be on the air for next week's show.
Yeah, we will. Hopefully you'll be with us. We'll find out. That's the question.
I hope I don't die.
You won't. It's just a tooth pulling.
Oh, you mean on the show? Oh,
on
gotcha.
the show. Okay. Oh dear. Shout outs to Richard Baker for taking care of book club business, to Patrick for his great work on the show notes, and to Alex for all his great work engineering this show. We love you guys. Thank you.
Yay.
Yay.
So if there's a story you'd like us to cover, research you'd like us to do ourselves. Is that how it goes?
Yeah, no. That's okay.
Okay, hang on. It's in here somewhere. How come I don't remember? We've been doing the show for 5 years. It's been the same outro.
For ages.
For the whole show. I mean, I do hope that people enjoyed the show, but I forget how to say that to them in a way that's consistent from week to week. And I will
and helpful given the information that they're going to need to take with them if they want to take action on things.
Yeah. All right, here we go.
Yeah.
All right, now we'll do a double take. This will all be edited out. None of this will make it to the real show. Thank you, everyone, for listening. We hope you enjoyed the show today. Twis is available also as a podcast. Just Google us in the iTunes directory for This Week in Science. If you have an Android device, you can look for us on Twis for Droid app in the Android marketplace.
And for more information on anything that you've heard here today, show notes are going to be available on our website, www.twis.org. We also want to hear from you. So email us at Kirsten@thisweekinscience.com or Justin at thisweekinscience.com.
No, Justin at twistminion@gmail.com, because the other email I still don't have. I haven't had for a month. 2 months. It's been a year? I think I haven't had it this year. Twistminion, all one word, @gmail.com. You can also, hit us up on the Twitter. It's at Dr. Kiki or at JacksonFly. We would love your feedback if there's a topic you would like us to cover or address. A suggestion for an interview or an insider stock tip, please let us know.
And we'll be back here, right here or there where you are next week. And we do hope that you'll join us again for more great science news.
And if you've learned anything from today's show, remember,
it's all in your head.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
rockstar
Woot!
pose.
Rockstar pose? Is that what you're doing now? Robot airplanes on Mars.
Huh? What did you just blurt?
Robot
Hell of a
airplanes.
blurt.
I know, right? It was pretty good. Robot airplanes on Mars. Gordon McLeod sent me a story from space.com that I didn't get to for the show, but it's pretty awesome. Researchers, scientists, atmospheric scientists specifically, this guy Joel Levine is suggesting that we need to take ROVs, so remote operational vehicles. Is that what they're? Anyway, remote control airplanes and fly them over the surface of Mars. That we need to send airplanes to Mars. We need to stop flying them over Los Angeles. We need to fly them over Mars and actually get an idea of what Mars looks like. Nice close up.
Yeah.
Yeah. Yeah, he says a powered airplane flying a mile above the surface can obtain measurements over inaccessible parts of Mars and collect a whole bunch of data that no rover can collect.
Plus, we can bomb the heck out of it that way.
Yeah, exactly.
Or bring democracy the heck out of it that way.
Bringing democracy to Mars. Yes, with airplanes. I love it. Levine has brainchilded the ARES, Aerial Regional Scale Environmental Surveyor project. There's a team of 250 people, from airplane designers to mission planners, who are developing this airplane, the ARES airplane, and they've built and tested a prototype that they're getting ready for the next solicitation for a Mars mission.